Okay, 8.1, solve the system of equations by graphing. So first thing you're going to want to do is get y by itself, and then we're going to identify the slope and the y-intercept, then we're going to graph. And just to give you an idea, once we've got y by itself, for instance, y equals 5x plus 2, you'll want to remember there are a couple things we can tell from this. When y is by itself, we know that the number in front of x is the slope, which is rise over run. So we can think of that as 5 over 1. This is the rise. This is the run. And the other thing that we can tell is that the 2 represents part of our y-intercept, and that the y-intercept would be 0, 2. That's enough to graph, and if we were going to graph that, we know that the slope is 5 over 1, the y-intercept is 0, 2, so we'd start out maybe plotting 0, 2, 0 on the x-axis, and then up 2 on the y-axis, so 0, 2 would be right there. And from that point, we're going to use the slope. We know we're going to rise 5 and run 1, so if we go from there up 1, 2, 3, 4, 5, our rise is 5 and our run is 1, so we're going to go over 1. And that means our graph should look something like this for that particular line. And on a lot of these, you'll be choosing from A, B, C, or D, and so you'll try to find one of those choices, A, B, C, or D, that's got both of the lines that you've drawn. And our solution of a system, by the way, is 2 equations. Those are the ones that we'll be looking at. The intersection of those 2 lines. So if we've got one line that looks similar to the one we just drew, and another line that we draw that maybe looks like that, the solution is actually this intersection point. And when we go to classify those, if there's one intersection point, like in this drawing here, that means this one would be consistent. If there's no intersection point, for example, if there are parallel lines, no intersection point, that would be inconsistent. And if it's the same line, in some cases you'll draw a line and you'll find out that the other equation is the exact same line, and that would be dependent. Otherwise, all these are independent. Okay, so let's take a look at an example, solve the system, and then we'll classify whether it's independent, dependent, consistent, or inconsistent. So we got x plus y equals 7, x minus y equals 3, so we're going to go ahead and solve for y. On that one, if we subtract x from both sides, we get y equals negative x plus 7. And if we do this one over, let's do that in a different color. Let's see, x minus y equals 3. Subtract x from both sides. You get negative y equals negative x plus 3. And then divide by negative 1 because we want to get that y by itself. So we get y equals, and that's a negative 1 in front of the x. So negative 1 over negative 1 is just 1. And then 3 over negative 1 is negative 3. So if we look at our equation on the left and our equation on the right, our slope here is negative 1 over 1, and our point would be 0, 7. That would be our y-intercept. Here our slope is 1 over 1. You could look at it like that. And our point is 0, negative 3. So if we're going to graph these, We know if we just look at the one on the left, we know it goes through 0, 7. So if we go ahead and graph that, 0 on the x-axis, up 7. 1, 2, 3, 4, 5, 6, 7. 0, 7 to be about there. And then our rise over run is negative 1 over 1. So down 1 and then over 1 would put us about right there. We can connect those 2 points, and our graph should look something like that. Remember, you're choosing A, B, C, or D, so you're just looking for the choice that looks the most like the graph that you've made. The other one, we've got 0, negative 3, so I'll put this in a different color. 0, negative 3, so down 1, 2, 3. 0, negative 3 is there. And then for the slope, it's 1 over 1, so we're going to go up 1 for our rise, and then over 1. So it'll look like that. So when you're choosing these, you're going to be looking for A, B, C, or D that looks similar to that. Since these only intersect at one place, this would be the solution. Not necessarily going to be writing that out in this case, but since there's one solution, that means this is consistent. Next up, 3x minus y equals 7. 3x plus 4y equals 2. If we want to go ahead and solve both of these. For y, 3x minus y equals 7. Subtract 3x from both sides. We got negative y equals, I'll put this negative 3x out front, plus 7. And divide by negative 1. So we got y equals negative 3 over 1 is just 3. 7 over negative 1 is negative 7. Work on the other one. 3x plus 4y equals 2. Trying to get the y by itself, we're going to subtract 3x. And then divide by 4. And then 2 over 4, it actually reduces. 2 over 4 reduces to 1/2. All right, so if we wanted to graph this, we've got our graph over here. And on the left, let me zoom back in real quick. 3 would be our slope, and our y-intercept would be 0, negative 7. So that 3 is going to be 3 over 1. And our slope here on the right one is negative 3 over 4. And our point is actually 0, 1/2. Okay, so if we look at the equation on the left, do that one in green. Let's do it in red. So 0, negative 7. So 0 on the x-axis, down 7. 3, 4, 5, 6, 7. So where that 0, negative 7 is going to be. And then from that point to the next, we're going to go up 3 over 1. So something like that. And in some cases, when you're choosing A, B, C, or D, you may be able to make your decision just based on the first line that you graph. Maybe only one of those choices, A, B, or C, or D, has a line that looks like this one we've drawn right here. But in most cases, it'd probably be a good idea to draw both lines. The other one we know goes through 0, 1/2. So if this were our 1 point, then this would be our 1/2 point. So something about right there. And then from there, we're going to go down 3 over 4, since our slope is negative 3 over 4. So rise is negative 3. 1, 2, 3, and then over 4. 1, 2, 3, 4. Okay, so you'd be looking for a graph that looks similar to that. And then, again, we've only got one intersection point. So consistent would be how we classify that. Next up, number 5, or example 3, 5x plus y equals 4, 6x plus 7y equals negative 30. Solve that one for y. 5x plus y equals 4. Subtract 5x. Subtract 6x. We got 7y equals negative 6x minus 30. Trying to get y by itself, so divide by 7. And then negative 30 over 7. So we'll look at a graph here. And for the left equation, we know that it goes through 0, 4. And that the slope is negative 5 over 1. So 0, 4, let's do that in green. 1, 2, 3, 4. So 0, 4 is going to go about right there. And then from there, we're going to go down 5 over 1. So down 5 and then over 1 be about right there. And then on the second one, we got a slope and a y-intercept. Actually, that's negative. Let me go back a little bit. Well, it's 0, negative 30 over 7, which it'll be helpful to know what that is as a mixed number, which is about negative 4 and 2/7, which is not quite negative 4.5, but somewhere in that area. So if we're graphing this, 0, negative 4 and 2/7, negative 1, negative 2, negative 3, negative 4, negative 5. So that'd be somewhere around there. Would be our 0, negative 30 over 7. Then from there, we know that our slope is negative 6/7. So from that point, we're going to go down 1, 2, 3, 4, 5, 6, and then over 7. 1, 2, 3, 4, 5, 6, 7. So something like that. Ooh. Not a pretty line, but we're just hoping to get a drawing that looks a lot like either A, B, C, or D. So hopefully we can narrow it down just based on this messy looking drawing I've made.